Okay, in this video, I'm going to go over an example of how to rationalize the denominator of a radical expression that has a binomial in the denominator. Okay, so let's get right to it. So the first thing I need to do is recognize what the binomial is, and I see it's 1 minus radical 3. And if you remember the technique to get rid of this, not to get rid of, but to rationalize the denominator is to use something called a conjugate. All right, let me just write that off here to the side. And you remember that a conjugate is the exact same terms as the binomial. So let me just go ahead and write this down here. 1 and then radical 3, but with the sign, the operation sign in the middle changed, right? So instead of a negative, you have a positive. So you always do the reverse. And again, since I'm just simplifying this problem, I want to multiply by 1 because that won't change the quantity of this problem, but it will help me rationalize the denominator. So I'm just going to multiply by the conjugate in the form of 1, right? Because 1 plus radical 3 over 1 plus radical 3 is equal to 1. So essentially what I'm doing is I'm multiplying this expression by 1 and then getting rid of the radicals in the denominator. Okay? Okay, so moving forward. What I've done here is I essentially have set up two simpler problems, right? I've set up a distribution problem up here in the numerator and a distribution problem down here in the denominator. So let's just go ahead and do each one of those individually and see where it brings us. So in the numerator, I'll just do something called a FOIL. I know some people don't like to use that term, but essentially what it is, it's a distribution with two binomials. So 2 times 1 gives me 2. 2 times radical 3 gives me 2 radical 3. Radical 2 times 1 gives me radical 2. And then finally, radical 2 times radical 3 gives me radical 6. Okay, doesn't look like there's any like terms there that I can actually consolidate. Now let's go to the denominator rather. 1 times 1 gives me 1. 1 times radical 3 gives me plus radical 3. Negative radical 3 times 1 gives me negative radical 3. And then finally, negative radical 3 times positive radical 3 gives me negative radical 9. Now, you can see that there are terms in here that I can start to cancel out and simplify, etc., but I kind of like to do them step by step, okay, rather than too much all in one fell swoop. So let's go ahead and do this. I know that my numerator is still the same, so let me just go ahead and do this. I could probably just put it in a different order, but I'm just going to leave it for right now and actually do more work with the denominator. I see that plus radical 3 and minus radical 3 actually will cancel out, right? And I know that the square root of 9 is actually equal to 3. So essentially what I have in the denominator is 1 minus 3. And notice now that my denominator now does not have a radical in it. Final answer, therefore, will be 2 plus 2 radical 3 plus radical 2 plus radical 6 all over negative 2. And remember that you can actually do equivalent expressions here. I can take that negative, maybe distribute it along the numerator, etc., etc. But essentially this would be a correct answer. Okay, hope that was helpful.